Lesson 11-4, Use Geometric Probability. By the end of today's lesson, we will be able to use lengths and areas to find geometric probabilities. The probability is a measure of the likelihood that an event will occur, so any number between 0 and 1. But for the geometric probability, it's the ratio that involves a geometric measure such as the length or area. So for the probability and length, let segment AB be a segment that contains the segment CD. If a point K on AB, so the K can be anywhere, on AB is chosen at random, then the probability that it is on CD is the ratio of the length of CD to the length of AB. So we can represent this symbolically by writing P, which represents probability, that K is on segment CD will just be simply CD over AB. Example 1. Find the probability that a point chosen at random on FK, so we're talking about this entire length, is on GH. So first we need to find the entire length of FK, which is just, so this is 5 units, and this is 6 units. So 5 plus 6 is 11 units. And then for GH, it's 3 plus 3, so 6 units. So this probability would just be GH over FK. So 6 over 11, which is about 54.5%. Example 2. A shuttle to town runs every 10 minutes. The ride from your boarding location to town takes 13 minutes. One afternoon, you arrive at the boarding location at 2:41. You want to get to town by 2:57. What is the probability that you will get there by 2:57? Now, first of all, you need to first find the longest time you can wait and still arrive by 2:57. So between 2:41 and 2:57, we have 16 minutes. And it takes 13 minutes to get from this location to the final destination. So we can take 16 minutes, subtract 13 minutes to get 3 minutes. And this will be our favorable wait time. So, which also means you must leave by 2:44. This point. So secondly, the train runs every 10 minutes. So this is our max wait time. So that the probability that you will get there by 2:57 would be probability to arrive by 2:57 is represented by favorable wait time over max wait time, maximum wait time. So that would be 3 over 10, which is 30%. So next we have the probability and area. Let J be a region that contains M. So J is the entire area and it contains M. If a point K in J is chosen at random, then the probability that it is in region M is the ratio of the area of M to the area of J. So symbolically, we can represent this as probability of K is in the region M will be area of M all over area of J. A golf ball is hit and stops on the green. A prize is won if it stops in the painted circle. The diameters of the green and circle are shown at the right. If the ball is equally likely to stop on any point on the green, what is the probability that the prize is won? So we need to use the area of the circle and find the area of the large circle and the small circle. So the area of the large circle is equal to pi 37.5 squared, which is about 4417.86. And the area of the small circle is equal to about pi times 7.5 squared, which is about 176.71. Now, to find out the probability that the prize is won, so here we need to take 176.71 and put it all over 4417.86. And this is about 0.039. So we can say 4%. Example 4. A homeowner's property is shown in the scale drawing. If a deer is equally likely to be anywhere on the property, estimate the probability that it is on the grass. So if we look at the top picture, you can see that the length is 8 and the width is 4. So we can say that the area of the grass is 4 times 8, which is just 32 square units. And to find the area of the entire property, we can look at the picture to the bottom and see how many full squares we have. So starting from this point, this is 5, this is 8, so we have 44 full squares, and then we have another 4 here, so 44, and then we can estimate a total of 3 partial squares. So that's going to be like, this is 1, and then 2, 3. So this part makes about 3 partial squares. So about 47 square units. And then we can find the probability that the deer will be on the grass. Area of grass over area of property. So that'll be 32 over 47, which is about 68%.